Hi everyone. Obviously I'm not at school today. I'm actually at home with a sick kid, but we need to go ahead and get set up for Unit 5 and take a look at 5.1 notes because they're super simple. So if you have not already done so, I need you to get out your spiral notebook and we're gonna flip to the end of Unit 4. So Unit 4 for me looks like it ended on page number 35. And so Unit 5 is gonna start right after that. So I'm just gonna flip the page. 36 is gonna stay blank. So here's a doodle page for you. And we're going to set up Unit 5 on page number 37. So if your page numbers don't match mine exactly, that's gonna be okay. It matters more so that your notes are in order. So it should be on 37, but if you're off by a page number, that's okay. So the table of contents page is gonna be passed out. When you get your table of contents page, you'll just tape down all four corners, and then this is what you're gonna fill in at the top. So this is Unit 5, and Unit 5 is all about solving systems of linear equations. So solving systems of linear equations. All right, so I'm gonna ask that this video be paused and y'all take care of that. So again, tape your unit table of contents down, go ahead and fill in the bubbles at the top. We'll worry about the tab that goes on the side. The next time I see you, we'll get that taken care of. So for now, just focus on getting this table of contents down. Go ahead and do that for me. You should have your table of contents page taped in now. Again, that went on page number 37. Don't worry about the tab. We'll take care of yours next time I see you. Now, the 5.1 notes, so lesson 5.1. We're gonna call this solving systems. Put a little colon right there, by graphing. That's what we're gonna focus on today. And we are going to tape this down onto page number 39. So remember, 38, it stays blank. It's any test information, a doodle page. We're gonna tape these notes onto page number 39. So here are the set of notes. It's just normal. You'll take it, fold it in half, and tape it down on page number 39. So let's pause this video. I need somebody to pass out notes to everybody, and then you guys get this taped down. I'll see you in a second. Let's go ahead and get started. So for 5.1, we're talking about solving systems of linear equations by graphing. Graphing is typically the easiest method to solving systems, so it's the one that we normally start out with. I will lead with saying this was taught in the 8th grade, but a lot of kids forget. So hopefully, as we go through this, some of that stuff starts to come back. If not that big of a deal, just learn it now. So, to start with a couple of definitions like always, a system of linear equations is a set of two or more equations in the same variables. In Algebra 1, we typically have two, so you won't deal with any that have three. We normally only have two equations that we're looking at the same time. Now, a solution of a system of linear equations is an ordered pair that is a solution of each equation in the system. So we're looking for an ordered pair. And now before we look at this first example right here, because this is the only one like this that we'll do for the front side, a number is a solution if you plug it into the equation and you get a true statement at the end. That's what it means to be a solution. And so when we talk about a solution to a system, the numbers are going to work for both equations, not just one, but it's got to work for both. So let's take a look at our example. It says determine if the ordered pair 2, 5 is a solution of the system below. So we're going to take 2, 5. This is your X value, that 5 is your Y value. So I'm going to color code stuff. Y'all know I like to color code. So we have a 2 and a 5. I'm going to take both of those numbers and I'm going to plug them into both of these equations to see if it gives me a true statement. So we're going to start with that first one. My X value is going to be that 2. My Y value is going to be that 5 right there. And I need to see, does it give me a true statement? So this first equation was X plus Y equals 7. But now I'm going to plug these numbers in there instead. So I'm going to have 2 plus 5 equals 7. So then I'm going to simplify this left-hand side. 2 plus 5 is 7. 7 equals 7 is a true statement. So 2, 5 is a solution to that first equation. Now my job is to go check the second one to see if it works for that one. If it works for the second one, then it's a solution to the system, which is both. So, same concept. I'm going to take this equation and I'm going to substitute in for the x and the y that I've got. So this one is 2x minus 3y equals negative 11. So again, I'm just going to substitute in. This time though, when I substitute, I need to make sure that I've got parentheses around it because there's a number already sitting there. So this is what this one looks like. 2. In that x spot, I'm going to plug in a 2 minus 3. And for that y spot, I'm going to plug in a 5. And then equals negative 11. Now we work to simplify. 2 times 2 is 4. Negative 3 times 5 is negative 15. 4 minus 15 is negative 11. And we end up with negative 11 equals negative 11, which is a true statement. So again, because it worked for both equations, that means it is a solution to the system. So let's write yes, it's a solution. Because our question up here said, determine if the ordered pair is a solution. We plugged it in, found out it worked for both equations, so that means yes, it is. Now, here's what you guys hopefully remember from middle school, but again, if not, it's not that big of a deal. We'll just get it now. So, when you are solving a system, okay, so it says solving a system of equations by graphing. A system of linear equations is a set of 2 or more equations graphed in the same coordinate plane. The same coordinate plane. Now, a solution of a system on a graph is the point of intersection. Now, this word right here, this intersection word, that's the mathematically correct word, but a lot of kids say this is where they cross each other, this is where the 2 lines touch, where they go through each other. All of those words mean the same thing. So we're going to graph 2 lines, and we're going to look to see where they cross each other, or their intersection. So, when you actually graph 2 lines on a coordinate plane, you end up with one of 3 scenarios. So here are your scenarios. Let's talk about the most common one first. So when you look at these 2 lines right here, you got to keep in mind that we are looking for where these 2 lines intersect or where they cross each other. This situation, they only cross one time. And so this has one solution. And it's wherever they cross. So, real simple. You see they cross, you identify the ordered pair, and you write one solution and then where the ordered pair actually is. Now, situation number 2 is created by what's called parallel lines. Those are 2 lines that they're never going to touch. They have the same slope, different y-intercept, so they're never going to touch. And when we talk about graphing a system of equations, we're looking for where they intersect. So if we have parallel lines and they never intersect, that means that there will be no solution to this particular situation. We don't see this one a whole lot, but every now and then they'll toss one in there. So we just got to be ready for it. Again, this one's created by parallel lines. Lastly, scenario number 3. This is created by identical lines. So here's what's happened with this one. Because you say, Coach Decker, we got to graph 2 lines. I only see one. That's because you've graphed one like this, and then you have graphed another one directly on top of it. So there are actually 2 lines there. We only see one though, because when you draw them, you only see one. So if we're looking for the point of intersection on these touch each other all of the time. They cross each other. They're laying directly on top of each other like this. And so we refer to this one as infinitely many solutions. Infinitely many solutions. I've heard some middle school teachers call that infinite solutions. It's the same thing. It just means that they're going to cross everywhere. Okay? So again, we've got 3 types of solutions. We got one solution. This is the one that we see 95% of the time. Every now and then you'll see this no solution situation. Rarely do we see this infinitely many, but every now and then they will put one on a test and we've got to be ready for it. So let's practice for a second. Real quick, it just says, what is the solution of the system? So we have 2 lines right here, 2 equations. Here are their lines when graphed on the coordinate plane. So we've graphed 2 lines, and all we're looking for is where these 2 lines intersect. And so I'm just going to put in a dot where those 2 lines intersect. They intersect 1 time, so I'll write 1 solution. And then I'm going to write at, then I need to list the ordered pair. That's the key. Anytime you have a system, you need to list what the solution is as an ordered pair. So if we count, right here is 0, 0. So I'm going to go -4, +5. So -4, +5. And this is my answer. And that's it. Now let's take a look at how to solve a system if it's not already graphed for you. If it's graphed for you, super sweet. But if not, it's not that difficult. You're just going to graph the 2 lines on this coordinate plane and then just see where they intersect. So I did try to type out the steps in order for you to follow along with them. So we're gonna talk through these steps, and then we're gonna actually do number 1 together as we work through these steps. So if you are going to try to solve by graphing, the first thing you have to do, step 1, is to make sure both equations are in slope-intercept form. That's step number 1. It's got to be in slope-intercept form for you to graph it. Now, slope-intercept form is y equals mx plus b. That's a little refresher. This is what our equations need to look like. If they don't look like that, then you just fix it. You manipulate the equation to make it look like this by adding or subtracting or whatever you need to do. So, like I said, we're going to do number 1. So when I glance down here, number 1, that first equation, y equals mx plus b, that one's good. Y equals mx plus b, that one's also good. So step 1's done. Step number 2, graph each equation in the coordinate plane. Got it. Now, my advice when you are going to graph these, you need to graph one at a time. Please do not try to graph both of them. If you try to graph both of them, it never ends well. So I'm going to cover up that second one up so that way we can focus on trying to graph this one. On this coordinate plane, we got a fresh, empty coordinate plane. So when you look at this, you need to start at your y-intercept, which is -8. So down here on my y-axis, I put me a dot at -8. My slope right here, even though I don't see a number there, there is an understood 1 right here. That's my slope, which is how I move it. Think rise over run to get more dots. So with a 1, I'm moving up 1, right 1, up 1, right 1, up 1, right 1. Now, here's another piece of advice I've got. Because we know this is a system, you need to try to get as many dots as you can. You need to make those dots kind of run off the graph a little bit because we are looking for where these 2 lines intersect. And so when we have dots, it's easier for us to see that. So there's line 1. Now I'm going to move my Post-it note because now we're ready to graph line 2. Line number 2, we're going to start there at +1. So I'm going to have a dot right there. And now this slope this time, all I see is a -2. You need to remember that every whole number that you see is over an understood 1. I should have talked about that on this last one. This one is a 1 over 1. This one is a -2 over 1. So from this dot that I put at +1, I'm going to move down 2, that handles the negative part, right 1, down 2, right 1, down 2, right 1. There's the dot they share. Down 2, right 1. And then here's my line. Now that I've graphed it, it's very easy to see that these two lines cross one time. It's right here, that one time. So over here, I'm gonna write one solution at, and then I need to list the ordered pair of where it happens. It is extremely important that you guys try to put all those dots because it's easier to see when you have the dots because it's easier to track back and forth. So for this one, it's going to be 3, -5. And there we go. There is our solution to our system. Now let's try one. Oh, you know what we did? We skipped step 3. So step number 2, I just went straight into it. Step number 2 was graph both of the equations in the same coordinate plane. Did that. Step number 3 says to identify the point of intersection. That's what we did. That's what that blue little circle is right there. And then I put 2 little asterisks right there. It says if there is only one solution, then the solution should be written as an ordered pair. Already did that part too on accident. My bad. I just got excited and skipped it. Now, what I was saying. Let's take a look at number 2 because number 2, those equations are not both in slope-intercept form, and so we do have to fix one of them. So this might be a situation that we run into at some point again. So looking at these, that top one is in slope-intercept form. The bottom one is not. So we're going to go ahead and actually graph that top one because there's nothing for us to fix with that one. So we're going to go straight into it. So again, I've blocked off that second one so that way I don't get confused at all. On this first one, the first dot goes at -3. So -3, there's my dot. And now that slope there is a 2/1. There's an understood 1 underneath there. And so from my dot, I'm gonna move up 2, right 1, up 2, right 1. Oh, I went 3. Make sure you count your spaces and not your lines, or else you'll mess up like I just did. Good news for me though, I've got whiteout. So let me just, there we go. All right, let's try again. Up 2, right 1, that's what I'm trying to do. Up 2, right 1. Now remember, because we're trying to get as many dots as we can, I'm gonna go a little bit this way because I don't know where it's gonna intersect. There we go. Got our line drawn. Now we're good. Now, this second equation, we do have to do a little bit of fixing too, because this it's not in slope-intercept form. It does not look like y equals mx plus b. It is a pretty easy fix to manipulate it and make it look like slope-intercept form. So here's how we do that. We need that y to be by itself, so I need to get rid of this 2x. It's a -2x, so I'm gonna add. So add 2x, add. This goes away over here. And I'm left with y equals 2x plus 4. This is now what I've got to go graph. So again, it's not difficult if it's not in slope-intercept form. You're just going to add or subtract the x to get it over there. You might have to divide, but that's as worse as it gets. So here's my second equation that I'm going to graph, starting up here at 4. I'll put me a dot at 4. And now again, that slope says 2. It's 2 over an understood 1 right here. So on my graph, I'm moving up 2, right 1. up 2, right 1, up 2, right 1. And then I'm going to get a few dots the other direction. Draw my lines. I'll give you a couple seconds to catch up. Now, you should hopefully have it graphed by now. If not, just keep going and you'll eventually catch up. When I first look at this graph, I might think to myself, ooh, I think I might have done something wrong because I think they're supposed to cross each other. And while that is a valid thought, remember, every now and then you're going to get a situation, and we even wrote it on the front, that there is no solution because they're created by parallel lines. These just happen to be a set of parallel lines, so they never intersect, which means there is no solution to this system. It doesn't happen often, but every now and then you'll see that parallel line situation. Just don't freak out and go with your gut, okay? All right. Number 3, this is the last one that I'm going to walk you through, and then I'm going to give you some time to do those practice problems over there on the right. So number 3, we get to do all of the steps for number 3, because when I first look at this, neither one of those equations are in slope-intercept form. So I'm going to have to do a teeny tiny bit of work to make sure that that is fixed before I go to graph it. So I have equation 1, equation 2. You're just going to I would recommend just starting with that first one. So for the first one, let me write it over here so that way we have a good amount of working space. Here's the first equation. All I did was copy it down. Now we're going to fix this and put it in slope-intercept form. So I'm trying to get that y there by itself. I'm going to subtract this 2x. I do want to mention one thing. Every now and then I'll get a couple of kids that think that they can combine these because this is the same number. While that is true, you cannot combine these because this one has an x on it and that one doesn't. So these are not like terms. So I've got y equals negative 2x minus 2. There's my first line. Now that I've got the slope-intercept form of that, I'm going to go ahead and graph it over there so that way I don't lose my spot. Starting with this second negative 2, the one at the back, that's what you graph first. So I got that dot right there. Now I'm going to deal with that slope of a negative 2. Keep in mind this is a negative 2 over a 1. So that means I'm going to move down to right 1. Down to right 1. Here's that side. Now I'm going to backtrack a little bit so that way I can get some other points like so. Oof, my line got a little janky right there, but it's going to work. This is why it's important to put dots on there. Now let's take a look at that second equation. The second equation is 2x plus 3y equals 6. Again, my goal is to get it in slope-intercept form, which is get that y by itself. So I'm going to start off the same way every time. Minus, you got to get rid of whatever that x variable is from the left, and you got to move it over. We end up with 3y is equal to negative 2x plus 6. That's a plus 6 because this was a positive 6 up here. Again, I cannot combine those because one has a variable, one does not. And lastly, for this one, we've got to divide by this 3. I've got to get rid of that 3 in the front of the y. So my equation this time, I'm just going to go simplify those fractions. We got negative 2 over 3x. 6 divided by 3 is 2. So I'm going to have a plus 2. That's as bad as it gets, by the way. If you have to change an equation, this is as bad as it's going to get. Now let's go graph it. Starting up there at plus 2, positive 2. My slope is negative 2 over 3. So that means I'm going to go down to right 3. Down to right 3. And then my other line, I can see that it's over here, so I'm going to go ahead and go the opposite way. So it's up to left 3, up to 3. And this is the dot that these two share. This one's a little bit closer together, which is fine. They still cross one time. So we have one solution, and it's at that spot right there. So I'm gonna have one solution at, and then you just gotta count. So this is 1, 2, -3, 4. And again, I want to stress, this is as bad as it gets. The worst case scenario is you're going to have two equations that are not in slope-intercept form that you have to convert before you can graph. That is not typically the case that we see, but this is worst case scenario. Normally, when you're using this method, it's going to be a lot more like number 1. So you'll have that one instead. All right, here's what I'd like you to try. Over there on the right, we've got some practice problems. There are only 4 of them, and so I would like you to try all 4 of them. And so before I have the substitute pause the video, I'm going to talk through each one of you and each one of them, and I want to explain kind of what I'm looking for. Number 1, determine if those points are a solution. Just plug that ordered pair in to see if it works out. Very similar to number 1 up here on the front if you need any extra help. Number 2 says identify the solution. This is very similar to this situation where you're naming what solution method it is. If there is a solution, you need to write it as an ordered pair. Number 3 is you need to actually graph this. Both of those are in slope-intercept form, so you can immediately start graphing. Graph it, check out where they intersect. And then number 4 down there, that error analysis, you guys know how to do those. I need you to describe and correct the error. So here's your graph, and I need you to fix the issue with this. 4 questions. Let's go. Some of these are going to take you a little bit of time, like especially number 3. It's probably going to take you about 2 minutes to do number 3. So let's go with like 6, 7 minutes. Let's do 7. So if I can, let's get the substitute to pause this video whenever I say in just a second. 7 minutes on the timer. I need you to try these just individually by yourself. And then at the end of those 7 minutes, I'm going to talk about one of them. Okay? So go ahead. Let's pause this. You've got 7 minutes. 7 minutes are up. So now let's go ahead and take a look at the correct answers so that way you've got the correct ones in your notes. To start, all you had to do was take those numbers right there from that order pair, plug them in. When you do, it fails over here because you end up with -4 = 4. That's not a true statement, so we just write no, it's not a solution. Simple. Down here, these next 3, we have one solution at 3, -2. Middle one is no solution. Last one solution at 2, 2. Again, this one is no solution because those are parallel lines. They never touch. I skipped 3 because I wanted to do that one with you. And then the error analysis question, the only issue, the graphs were great. They were in the right spots. The only issue was this x = 2. When you are naming a solution to a system of equations, it really needs to be an ordered pair. So you need to include the whole thing, the x and the y value. So 2, 3. Now, number 3. This is the one that most people struggle with because equation number 1, it gets people, okay? So equation number 1, it's actually in slope-intercept form. It's y = -1. That is your y-intercept. So it's going to be -1, but there is 0 slope. So there you do not see that x. It's the 0x. 0 slope is a straight sideways line like this. So I'm going to draw that straight sideways line. Looks like that. And now we're done with that first one. Second one, we're going to start with that y-intercept of 4. And then you're just counting. Down 5, right 2. Down 5, right 2. Here, I missed just a little bit, but again, focus on the dots. This is why it's important to have the dots, because my line just barely missed, but it's at that point right there. So we have one solution here. at, we're looking at 2, -1. And that's our solution. So to wrap this up, the whole point of today was being able to graph two lines on the same coordinate plane and talk about where they intersect. We typically have 3 options when this happens. Here they are. This is the one that we see 95% of the time, and then you got this little scenario and this last one over here. Again, we typically see this one 95% of the time. So when I come back to work and I see you guys next time, we're going to quickly review this, and then we're going to move on to the next method to solving systems, which is called substitution. So good work today. I hate that I wasn't at school, but I will see you guys soon. Bye.